Hello everyone, welcome to another video. This is part 2 of Docker for DevOps crash course. So this is the continuation from part 1. So if you have not watched part 1, I highly recommend that you watch that one and then come back to this one. In that way you'll be able to learn the things in a better way. Alright, so today I will be covering the layers of a Docker or a container image, and then we're going to deep dive into Dockerfile, which is the basis of a Docker image. So you need a Docker file to create a Docker image. So we will deep dive into the concepts of a Docker file, and we'll see how to write a Docker file, okay, and then how to use it to build an image, and then to use that image to create a container. Okay, so let's start with understanding the layers of a container image or a Docker image. So each image that you build is a composition of different layers, okay? And whatever layers are there in the image, it is already defined in the Docker file, because a Docker file is the basis of a Docker image. So whatever instructions you define in your Docker file, it's going to give the different layers to that Docker image when you build it. Okay, so let me go to my terminal and show you that how it looks. So let's see what all images we already have. So these are the images that I have. So let me show you the layers of the image that I built, which is Apache 2 Tech. Okay, so to see the layers of a Docker image, you can run command docker image history command. So docker image history, it's going to give you the history of a Docker image and then the name of the image. In our case, it is this image. And also let me just cat the Docker file as well, which was used to create this Docker image. And let's try to understand these different layers of the image. Okay, so as you can see, what I did, I just ran this command docker image history and then the name of the image, and it gave me the different layers of my Docker image, how this image was built. So start from this last line here. So if you see here, these steps till here, these steps are for my base image. Okay, then how do I know it? If you see this created time, these were created like 4 weeks ago, which means that this Ubuntu image was updated like 4 weeks ago. Okay, so all these different layers, all these different steps that you see till here, it's all related to my base image, because my Docker image is only 4 days old. Okay, so which means that I built this image just 4 days ago, which means that I only added these layers to my image because I'm using a ready-made base image in my Docker file, as you can see, from Ubuntu. So this Ubuntu was built with these layers. Okay, and then all the other steps are from my Docker file, starting from here. Okay, and also I already know that when you use this Ubuntu base image, the default command that runs in this Ubuntu image, it's /bin/bash. Okay, so it only has a shell inside it. When you use this image, if you run a container out of this image, Ubuntu image, it's only going to run this shell. Okay, so I already know about that, but I also checked this creation date, which is 4 weeks ago. Okay, so this is all related to my Ubuntu image, which is the base image. Then if you see, after this base image, the second step in my Docker file is run apt-get update, which is this one. So this is the layer that is defining my second step, which is run apt-get update. Then similarly, I'm using this third instruction here, which is an arg or an argument, where I'm using this Debian_frontend is equal to non-interactive. So here you can see this is the third step. Then run apt-get -y install Apache 2. So I'm trying to install Apache 2 package here. So for that, I'm using this run instruction. So this is my that step where I'm installing the Apache 2. So this is how they have represented this step. Okay, so don't get confused. This is the step for this one where I'm trying to install Apache 2. So this is how they are representing in the Docker image history command. Then the next one is I'm adding this index.html file to //www/html inside my Docker image. So this is that step. And at the end, I'm trying to start my Apache server. So this is the command that I'm trying to use to start my Apache service. Okay, so this is this step. So this command is used to check the layers of your Docker image that you built. Okay, let's now understand what is a Docker file. So Docker can build images automatically by reading the instructions from a Docker file. This we already understood in our last video also. So to create a Docker image, you need a Docker file. Okay, so Docker file is just a text document that contains all the commands a user could call on the command line to assemble an image. It means that it is just a simple text document with instructions of how your Docker image should be built. Okay, so this is the very simple definition of Docker file. And now let's see it in real time on a terminal. So let me clear my screen. So let me just open this Docker file which I already have. So another thing is, when you write Docker file, the default way to name the Docker file is you should use a capital D always, and this is the name that you should keep, Vim Docker file, which means that you don't have to specify any additional flags when you are building your Docker image if you use this name. If you use another name, then you have to add an additional flag, and then you have to specify which file do you want your build command to build your image from. Okay, so this is the standard way, or we can say the default way of naming a Docker file. Okay, D capital and a Docker file in without any space, like this. So let me open this Docker file which I already have on my virtual machine. So as you can see, as from the definition, Docker file is just a text file with some instructions that you need to build your Docker image. Okay, now how do I know which instructions should I be using? Okay, so to refer to that, I have given you one documentation URL. This is the official documentation of Docker, where you can find the different instructions that you can use in your Docker file. Okay, so if I have to build a Docker file, how would I do it from scratch? So suppose I want to build a web server. Okay, I'm just giving you a very random example so that you can think of it, how you can start writing a Docker file on your own. Okay, suppose you need to run a web server from Apache. Okay, you want to containerize an application. This application is going to be a web server, and it's going to use Apache as the package, as the web server package. So how would you start? Okay, so what happens these days? Okay, if you see we have various different Linux operating systems available to us, but from a developer point of view, if you see, Ubuntu is one of the best operating systems out there that is used by all the developers to do their development work. Okay, this is like the default setting. You can say the default operating system that they use is going to be Ubuntu until they have some specific requirement. Okay, so if you are a developer and you want to build an application, okay, so you are going to use Ubuntu by default. Okay, so that is why I'm using the Ubuntu as my base image. So whenever you want to start writing your Docker file to build a Docker image, you have to start from the base image, and you have to specify a from parameter always. A Docker file is going to start from. Okay, so if I go back to the references page here also, you can see from, which means create a new build stage from a base image. So it's always going to be a base image to get started. It is always going to be a from statement at the top of a Docker file. Then after I have my operating system, I need to see what all things I need to keep in my Docker image. Okay, so that my this Apache 2 is able to run successfully without any issues. So the first thing that I want to do is I want to update this Ubuntu packages. I mean all the packages. I want to update all the packages in this Ubuntu base image. So to run any command in a Docker file, you can use run instruction. Run. Once again, if I go back to the references page, you can see run. Run means execute build commands. Okay, so whenever you have to run any command inside a Docker image, you can use run. Okay, to install any packages. For example, you want to update the system packages, you have to install some other dependency packages for your application. So all that can be done using the run command. Then I'm using this arg, which stands for argument. Okay, so basically this arg is to include some environment variables. Okay, so what I'm specifying here, I'm specifying Debian underscore frontend is equal to non-interactive, which means that all the commands should be run without me having to interact with the operating system at all. Okay, so this is like a given variable that is available in your with your Ubuntu base image that you can use. Okay, so I'm using this just to specify that I will not be interacting with this image. Please go ahead and install everything that is included in my Docker file without me having to do anything with it. Okay, so I'm using this argument. Once again, you can go to references and see the meaning of arg. Arg means use build time variables, which means using the environment variables. Okay, next is again I'm using apt because I want to install this Apache 2 package on my Ubuntu base image. So after I've updated my system packages on Ubuntu, I've specified one environment variable. Then I'm trying to install my Apache 2 package. So apt-get -y install Apache 2 is the standard command in Ubuntu to install any package. So to include this command in your Docker file, you will again use the run instruction so that you can install this package. Okay, then what I'm trying to do is next is after I install this package, I'm trying to copy the default file. If you remember this Apache 2 package, it uses a default index.html file to be served on the website when your Apache 2 web server runs. Okay, so to copy any files from my virtual machine to inside of my Docker image, I can use the add parameter again, add instructions. Once again, you can go to the reference, this documentation page and see add. Add is to add local or remote files and directories. Okay, so I want to add this index.html file from my virtual machine to inside of the Docker image in this path, because this is the default path from where this Apache 2 is going to serve the website. It's going to be /www/html. And here if you see, I'm not specifying any path, which means that this file is available in the same location as my Docker file. If this file is available somewhere else, then here you have to specify the absolute path of the file so that when you are building the Docker image, it is able to find this file. Okay, then again at the end, I'm using the CMD parameter. CMD parameter is used to specify the command that you're going to run when a container is created from this Docker image. Okay, for that you have to use CMD parameter, which is the default command that is going to run your to start your container from this Docker image. Once again, I can go to this reference page and see the run. Run is execute build commands. Okay, but sorry, not run, but CMD. So CMD is specified default commands. Okay, which means that the command that you want the container to run when it is created from a particular Docker image, which is going to be this image. Okay, and this is the standard command that you have to run to start your Apache 2 web server. Okay, so that's all I want to do, right, in this Docker image. So let's just come out of it, and we've already built this Docker image. Okay, but let's just try to build it again. Okay, so let's see the tag that I was using earlier on. So this is my image that I was using. Okay, and you can check the history command also. So this is the image that I created, this one. Okay, so let's try to tag this image with some other name. So let's do Docker. So once again, I am inside this directory, my home directory of Ubuntu user, and I have two files here. I have the Docker file and I have the main index.html file. Okay, so if I do Docker build, I can tag it. Okay, so let's tag with my username of Docker Hub and my repository name and the version of my Docker image, okay, which is going to be v2 in this case. So let's just do this same name, but version it's going to be v2. Okay, and then I have to specify the build context, which means where is your Docker file. Okay, if you're running this command in the same location where your Docker file and all the other files that you are going to use in this Docker image are present, then you can specify this dot, which specifies the present working directory. This means that my Docker file and all other files that I want to use in my Docker image are available in the present working directory. So you can do this and hit enter. If you see, this image built really fast. Okay, this is because whenever you build any Docker image, okay, whatever layers you have already built, those layers are going to be remain in the build cache. And when you run this command, it is only going to build the steps which have changed. Else it is going to take everything from cache. You can see here, cached, cached, cached. Okay, so it's going to take all the things that are available in cache from the build cache. So it is not going to rerun it. So once again, it's going to save a lot of time as well, and it is very efficient also. So the thing that actually changed is the name, because I'm using a different version to this image. So that's all that is changed. Okay, now if I do Docker images, so you can see I have this new version. Okay, but once again it's going to show the same because this image was already created 4 days ago. I just changed the tag of this image, and if you see these 3 results, but it's actually just one image with different tags. So it is only going to take 245 MBs. Okay, it does not mean that it is taking 245 MB for each of these tagged images. It is only going to take 245 MB for all the 3 images that are exactly the same, but only the tag is different. Okay, now if I have to create the container out of it, I can do Docker run -d in detached mode, then -p because I want to expose this web server on a particular port. So on the host, let's use port 8081, and inside the container, this Apache 2 is going to run on port 80. Okay, it runs on port 80, and so this is the default web server port in Apache 2. It's going to be 80 by default, okay, on which this container is going to run. Okay, so I'm just trying to map this port inside the container to a port on my virtual machine so that I can access this container application on my virtual machine on port 8081. Then it's going to be the name of the image. So let's use, let me run the command again. It's going to be docker run -d -p, and then the name of the image, which is going to be, and version is going to be v2. I can also name this container. For that, let's add -name. So this is going to name the container. Let's use this as web app and hit enter. You see this long ID, this is your container ID. If I do docker ps, I can see this container is running now. Okay, just 7 seconds ago, and it is running on port 80 inside the container, and on my virtual machine it is running on 8081. Okay, now I have to copy the copy the public IP of my machine, which is this one is the IP of my virtual machine. Okay, it's going to be the public IP address. So let's go here and enter this IP. I'll just make the corrections. So this is my IP address and port is going to be 8081. I may not have allowed the port on the security group, so I'll have to check that. Yeah, so I think this port 8081 is not allowed on my AWS EC2 security group, and that's why it's failing. So let's do one thing. Let's to save some time, let me just use port 80 here. I believe port 80 is open on my security group. So let's run the container again with port 80. And since I've already created it, since I already have this name on my container web app, so I will not be able to use it again. So I have to use web app 2. Done. And now if I run it on port 80 instead of 8081, it should work. Yep, it's working. So this is the default index.html page that is that I wanted to run. So this is running inside a container. Okay. Now, so you can run this similar application without a container also. Okay. So let's see that. So let me go back to my terminal and let's get the Docker file. So whatever steps you have here inside your Docker file, okay, to create a Docker image and then create a Docker container, similar steps you can use on your main virtual machine to run an application. Okay, so how would you do that? Let me become root first, because by default when I'm running these commands, I'm running these commands as root. So I'm root now, and what I'll do is I'm going to update the package first. So let's do apt get update. Okay, as it is given in the Docker file. Okay, I don't need to set this environment variable because I am currently I can currently interact with my virtual machine to install anything. So I don't need to specify this particular argument here. I only specified it inside the Docker image so that I do not have to interact with it, and I can install all the packages automatically. Okay, so then the next is I have to install this Apache 2 package. So I can copy and paste it like this. Can install the package. Next is I have to copy this index.html file to var www.html. So let's do that. So I switch to root. So I'm under /root. So what I'll do is I'll copy the file from my home user directory of Ubuntu user. So /home/ubuntu/index.html should be copied to /var/www/html directory. Right? It's done. So after this, it's going to be after copying the files to this directory, then I have to run this command to start my Apache web server. Okay, so I can just copy this command as it is from the Docker file and try to run this command, but I just have to remove all the things that I don't need to run this command from the terminal. So this is the command that is used to start my Apache server. Okay, let's try to run this command. Okay, I am getting an error. It says address already in use, make underscore sock could not bind to address 80. Then I'm seeing this no listening sockets available, shutting down, unable to open logs. Okay, so what it means is since I'm running this Apache server, so by default when you install Apache, it runs on port 80. Okay, in the configuration file you can see it's going to run on port 80 by default. But since I already have one container running on port 80, okay, so in Linux, remember, each port can only be assigned to one process at a time. If any process is already attached to a port, that port cannot be used for any other process. Okay, so when you ran this container, okay, this container application for Apache 2, it was running on port 80. So this port 80 is already attached to that container process. And when I'm trying to start this Apache CTL, I mean Apache service on my virtual machine, it is also trying to attach to the same port, but that port is already in use, so I cannot use that port. Okay, so what we can do is, let me see the containers. So as you can see, port 80, so I can just get rid of this container. Okay, so let's just copy this ID from here and do docker rm. I'm going to do it forcefully because the container is in running status. So I'm trying to remove this container forcefully. So docker rm for remove, -f for force, and then the container ID. Container is removed. Okay, if I do docker ps again, I won't see that port 81, port 80 container running. Okay, now I can run the same command and let's see if it's going to start my container. Okay, let's go to my browser window and see. Yep, it's working. Yes, it's working, as you can see. So since I'm running this command in foreground, it has been attached to my terminal. Okay, so I don't get my, I won't get my terminal back because I'm running this command in foreground. Okay, so I'm able to access the website. I know I don't have the container. We already saw that the container has been terminated, deleted. So I don't have the container process running for my Apache web server on port 80, but I'm able to access the website using this this Apache web server that I'm running on my virtual machine. Okay, that's why I'm able to access the website. Now if I just come out of it, Control C, and if I try to access this again, I won't, because the process for Apache has been stopped, okay, on my virtual machine, so it is gone. Okay, so it's not going to work. It's going to fail after a few minutes. Then what I can do is, if I run the same command in the background, so let's use background. So I will get my terminal back. So let's go to this again and refresh, and you can see I can access this container again. I'm sorry, not container, but I can access the application that I installed on my virtual machine, okay, without a container. So as you can see, it's the same thing. Whatever commands you are using, if I do history here, so whatever commands you are using here from your local virtual machine, like this apt-get update, apt-get install Apache 2, and then you copied this index.html file to this directory /var/www/html, then you run this command to start your Apache web server. So all these commands I just copied and pasted in my Docker file. Okay, if you see your Docker file, it's the same thing. So it's not available here. I need to go to /home/ubuntu. So if I do cat Docker file, so you can see all the commands are same. So it's the same thing. You can run an application without a container or with a container. Okay, but as we know what container is able to do for us, it's able to give us an isolated environment where we can have all the libraries, dependencies of a particular application inside it. If we want to update any particular package or its dependency, we can do so without impacting other applications that are also running on the same virtual machine. Okay, so that is why we want to use containers, but the things that we do on a normal virtual machine are exactly the same that we do inside a container to run an application. So all these commands are same. Okay, apt-get update, apt-get update, apt-get -y install Apache 2, install Apache 2. Then I copied the file index.html file, similarly here, and then I started the container process using this command, and the same command I used, it started my container. So it started my application on my virtual machine, and I was able to access it. The only command that I added is this one, because I wanted to run these commands without I having to interact with the Docker image. Okay, so this is how you do it. So you can run the application locally without container first, and then you can copy and paste these steps into a Docker file, and then run this docker build command after you install Docker on your virtual machine, and you can create a Docker image and then run it as a container using the docker run command, and then try to access the application. So this is how it works in a real time also. Of course, this application is pretty simple. The main production grade application is going to be much more complex, but this is going to give you an idea how a developer actually containerizes an application, a developer or a DevOps engineer. Okay, so how do you containerize the application? First, you have to run the application locally on your development machine to see if it is working. Then you just have to copy and paste all the steps which you ran on your local machine to a file called Docker file, and then install Docker, and then run the Docker build command to build your image. Okay, and then you have to run docker run command to start a container from that image. Okay, so this is how it works in real time. This is the real workflow that happens when you are working for a company. Okay, I hope the concept is clear to you. Okay, if you still have doubts, please reach out to me. All right, so that's all I wanted to cover in this video. Okay, I wanted to cover Docker file and the layers of the Docker image. Okay, so yep, that's it for this video. If you liked it, please hit the like button, please share this with your friends, please do subscribe to my channel, and yep, I'm going to see you in the next one. Bye for now.